Hey everyone, welcome back to Widget Wisdom. Today we are diving deep into state management with Riverpod, a powerful alternative to the provider package in Flutter. Riverpod is designed to be more flexible, testable, and scalable. In this session, we will be covering the essential of Riverpod and how you can use it in your Flutter apps. Let's start by discussing what Riverpod is and why you might choose it over other state management solutions. So, what exactly is Riverpod? Riverpod is a reactive state management library created by the same developer behind Provider, but it takes a different approach. It eliminates the need for build context and provides more compile time safety. Unlike Provider, Riverpod lets you define providers outside the widget tree, which is especially useful for testing and non-UI related state. Now let's get into the details of setting it up and how we can use it in our apps. So first thing first, let's install Riverpod in your Flutter project. So for that, open the pubspec.yaml file and then come to dependencies section and here add the Flutter Riverpod dependency. Now tap on the pubget option to get all the dependency. Once installed, now we need to wrap our app in a provider scope. So this is similar to multi-provider in Provider but with more flexibility. So let's do that. But before doing that, let's define a class to hold our immutable data. For example, let's create a configuration class. So here I'm creating a new Dart file as app-config. Now come inside this file and here create a class as app-config. And here we are going to store the app name and API URL. So these are the immutable data which never going to be changed. Okay, once they are defined, they are always going to be same unless we are not editing these value inside the main function. So here I have added the app name and API URL to variables. Then create the constructor for this class and make sure to mark all the fields as required. Then come above here of this class and here let's create the provider for this immutable data. So here create a new variable as app-config provider. Then here add the provider and then inside the angle brackets here add the type of provider. Like you are creating provider for which class. So here we are creating the provider for app config. So here add the app config. So now this means that this app config provider is the instance of this app config class. Then here we need to add the closure function and this closure will have a single parameter, that is the ref. So this is a reference to the provider itself and it can be used for accessing other providers or keeping track of the provider's life cycle. In this case, it's not used actively, but it's required to implement the function signature. And then from here, just simply return the app config. Okay. Now inside the app config, there are two required parameters. First one is the app name and second is the API URL. So here let's add the app name as Riverpod example. And for the API URL, let's throw some random shit here. Now, this was the part where we create the provider. So basically here this app config provider provides an instance of app config when accessed, and since provider is used, the data returned by app config provider is static and immutable and it won't change during the lifetime of the app, making it ideal for configuration data such as API URL, app name or constant used throughout the app. Any widget can use this provider to access the configuration and setting. So let's see how we can create a widget which will use this data. So for that, first go to the main.dart file and then here come inside this main function. And from here, remove this my app and here first add the provider scope inside the run app. So this provider scope is a crucial widget when using Riverpod for state management. It acts as the root for all the providers in the app and it wraps the entire app, meaning any provider defined in our app will be accessible to all descendant widget. Without wrapping the app in provider scope, Riverpod cannot manage state or dependencies. Okay, so this was the main purpose of adding provider scope here. Then here add the child widget and then here you can simply call your widget which you want to call. So in our case, here we need to call the my app. So here call the my app. Okay. Now let's see how we can consume the data of the provider. So for that, remove this my home page from here and here create a new class as home screen. And now here's the interesting part. Up until now, you have seen in all the widgets that we are extending stateless and stateful widget. But when we are using Riverpod, we have to extend the stateless widget with the consumer widget, because this widget is a special type of stateless widget provided by the Riverpod, and it allows access to providers through a widgetref object, which is passed into the build method. Okay. Now here you can see that we have an error that it's missing an override function. So please override the function, and this is the build function. Now again, up until now you have seen that in the build method we always have the context, but you may ask that what is this ref thing? So this is the object which is used to interact with Riverpod providers. In this case, ref is used to access the app config provider. Now for showing the details, here we need the access of app configuration using the provider. So for that, here create a new variable as app config, then here add the ref.watch, and then add the provider name. So here we have defined our provider name as app config provider. So here add the app config provider. Now you may ask that what is this ref.watch? So ref, as I have told you, this is the reference of this app config, and this watch is a function that subscribes to the provider. So if the provider's value changes, the widget rebuilds automatically. Since provider gives immutable data, this won't change once it's set, because this app config provider is providing the static data. Okay, so there is no need of changing this. Then this app config provider is a provider that we have defined a few minutes ago that supplies an immutable app config object, and this app config object containing static data. Then from here return a scaffold widget, and for app bar here just simply add the app bar widget. Then for its title here add a text widget, and now here we are going to show the app name. So for accessing the app name, here just call the app config and then access the app name. So this app name is directly coming from the app config class. Then for body here add a center widget, and for child do the same. Here just add the API URL and then access the API URL from this app config object. So this will give us the API URL. Now if you save the code and run the application, then you can see we have our app name and the API URL as the same as we have defined inside the provider. So this is how a static provider works. So now let's summarize this code. Here we have consumer widget. So it simplifies accessing providers without having to manually wrap the widget in a consumer. It provides the ref object that allows you to access and interact with providers in the build method. Then we have this ref.watch. So this is the method used to read the value of the app config provider or any widget in the widget. In this case, provider is immutable, meaning the data is static and it does not change during the app's life cycle. Then we have that app config class. So this contains a static data like app name and API URL, and this class holds the configuration settings used throughout the app. Now let's move to the next thing. So after the provider we have state provider. So we use state provider for mutable state. It's often used for things like counters, toggles, or any variable you need to change. So let's see the example of the state provider. So for the example, we are going to create a counter application. Okay, so for counter application we need to define a state provider for the counter, and it's recommended to create the provider in a separate file. So here just create a simple separate file and name it as counter provider. Now come inside this Dart file and here create the first variable as final counter provider. Then here add the state provider, and this is the counter application, so the value type is going to be int. So inside the angle bracket here mention int. So this creates an instance of state provider that holds a state of type int, and the type parameter int indicates that this provider will manage an integer value. Okay, now the state provider needs an anonymous function, or you can also call it a closer. So this will going to take a single parameter, that is ref. So this ref parameter provides access to other provider and allows for reading or watching their states. So here add that, then add the curly braces, and from here return 0. So this 0 is going to be the initial value of the counter. So this means that whenever the counter provider is accessed for the first time, its value will be 0. So here we created a state provider using Riverpod to manage a mutable integer state specifically for a counter, and the counter is initialized to 0, and this provider can be accessed throughout the app to read or update the counter's value. Now that was it for the state provider part. Now come to the main file. Now let's jump to the interesting part. So here let's create a new class as counter screen, and now it's not going to extend the stateless or stateful widget. Rather than it going to be extend consumer widget, and by extending consumer widget it gains the ability to listen to provider and rebuild whenever the state changes. Then here our class is showing an error that an override is missing. So here just override the missing function, and that missing function is the build method. So here just add the build method, and in all the stateless or stateful widget you always have seen this context. But now here you may ask that what is this widget ref? So this is a reference to the widget tree, allowing the widget to interact with provider like reading or watching their state. Then here we need to create the instance of our counter provider. Okay, so for that here create a final variable as counter, then here add the ref dot watch, and then the counter provider. So this ref watch counter provider, this subscribes to the counter provider, allowing the widget to rebuild whenever the counter state changes, retrieves the actual integer value held by the counter provider. In this case it represents the current counter value, and here add the scaffold widget, and then for app bar here add the app bar widget, and then for title here just simply say the counter example. Okay, now for body add the center widget, and inside the center widget here add the child widget as text, and then let's say we are going to show the counter value here. So here add the counter value, and then dollar counter, and here add the text style and add the font size as 24. So using this text widget we are going to show the current counter value. Then come outside of the body and here add the floating action button. Then for its child here just add the add icon, and then for on pressed here add the ref, then add the read, and then the counter provider, and then state. And as you know this state is int value because that's what we have defined in the counter provider. So whenever user will press onto this add icon button, then we need to add the 1 to the current counter value. So basically here just add the plus plus symbol to increment the value. Now if you save the code and run the application, and now when I'm tapping onto this plus button, then you can see our counter value is increasing. As the same way you can also create a function of decrement counter. I know it's not a good idea, but let me demonstrate you this. So here instead of this plus plus just simply add the minus minus. Okay, so this will going to decrement the value. Now if you save the code and run the application, and now you can see when I'm tapping onto this button, then our counter value is decrementing. So in this example we have seen that how we can use the state provider for mutable state, and in the mutable state the value is going to be changed all the time. Okay, now let's move to the another type of provider, that is the future provider. So the future provider is perfect for handling asynchronous operations like fetching data from an API. So let's also see the example of this. So for that create a new Dart file as postmodel.data, and inside this class first we are going to define a model for our data, and for this specific provider type I'm going to use the JSON placeholders API. Okay, then after the model we are going to define a future provider for fetching the data from an API. So let's first create the model. Okay, so inside our post we are going to have three things: ID, title and body. So here just add these three parameters as ID, title and body. Then here create the constructor of this class and mark all of the fields as required. Okay, then create the post.fromJSON method, and don't forget to mark this method as factory because This is a factory constructor for the post class, and its primary purpose is to create an instance of the post class from the JSON object. Okay, so this method will going to take only single parameter, which is going to be JSON. So this is the map representing the JSON object, and from this method just return a post, and then here add the ID as JSON ID. Then for title do the same, and then for body do the same. So this will create the instance of post. Now let's define the future provider for the fetching data. So here create the data provider variable, then here add the future provider, and its return type is going to be list of post. Okay, so inside the angle bracket here add list and then post, and as like state provider, this is also going to be as the closer. So here first add the ref, and then it's a future provider, like we are using this provider for the API call. So here we need to add the async. So here add the async, then inside the curly braces here just create the simple response variable, then here add the await because we are waiting for the request to be complete. So here add the http.get, and then and one more thing, don't forget to add the http package in your pubspec.yaml file. So come to the pubspec.yaml file, and here first add the http package, then tap on this pubget option to get all the dependencies, then come inside this class and here import the http, and don't forget to import it as http. Okay, then here inside the get method we need to parse the string URL into the URI. So here add the URI.parse, then add the URL. Okay, now after this here just simply we need to add few checks that data is correct or not. So here just simply add a check that if status code is 200, then server returns an OK response, and here we need to pass the JSON. So here just simply create a dynamic list, and let's name it as JSON data, and then decode the JSON from the response body. So here add the JSON.decode and then the response body. Then from here we need to return the post. So here just simply add the JSON data map and then return the post from JSON to list. So this will going to return the list of post class, and then here add the else condition if something went wrong. So if something went wrong, then we are going to throw an exception. So here just add the throw exception and fail to load post. So this was it for the post class. Now let's create a new screen and let's name it as post screen, and this is also going to be extend the consumer provider like the counter screen. So here extend this with the consumer provide, and then here override the build method. Okay, now here we need to watch for the future provider, like when the data comes or when the data updated. So here just add the async post, and then here add the ref.watch and then the data provider. And don't worry, this is the same data provider which you have created in your post model class. Okay, now come inside the return section, and from here remove this empty placeholder and here add the scaffold widget. Then for app bar, just simply add the app bar widget with the title as post, and then for body here add the async posts dot when. So this method handles the different states of the provider, and it have few state like data which going to display the data. Then we have loading. So here we are going to show a loading indicator while the data is being fetched, and if in any case we have an error, so we will display the error by using the error state. So first let's see the data state. So here add the data keyword. Okay, then it will going to give the posts. So here add the posts, then from here just simply return a list view.builder, and here this posts is the response from the server. So this is our list of posts. So for item count here add the posts.length, then for item builder add the context and index, and from here you can create a new variable for storing the single post, or you can simply use the posts index. Okay, but here I want to create the one more variable for the single post. So here I'm just added the final post which will store the value of posts and then current index. Okay, then from here just simply return a list style, and for title here add the text widget which will show post.title, and then for subtitle here just add the text widget which will show the post.body. Now come outside of this data, and then here add the loading state. So when there is a loading, then we are going to show a circular progress indicator. So for that, here at the center widget, and then for its child, here at the circular progress indicator. Then the third state is error. So for error, it will going to give us the error and the stack. Okay. So for here, just to simply return a center widget, and its child is going to be text widget, and here we are going to show the error. So here the mention error and then the error. So this will show the error. Okay. Now if you save the code and run the application, then you can see when the data is loading, we are seeing a circular progress indicator, and then we have the list of posts. And in any case, if my internet is off, let's disconnect me through my internet. So I have disconnected my internet. Now if I save the code and run the application, then you can see I'm simply just seeing an error. So this is how you can add the feature provider in Flutter. Now let's see how we can use the stream provider for managing the streams of data, such as real-time update from a server. But this video is already too long, so I'm not going to show you how to use stream provider. If this video will have 25 comments, then I'll create a new video in which I'm going to explain the stream provider. So that was the one part of this Flutter Riverpod thing. Now for more complex state management, Riverpod offers the state notifier provider, and this state notifier allows you to encapsulate complex logic and mutations. And we also have async value for handling asynchronous states and a lot more things. But this video is already 20 to 25 minutes long, and I'm not going to cover all of those things in this video. And if you want to see the example of all of those things, then please comment down below. If this video will have 25 comments, then I'll add the video for those things. Now let's compare the Riverpod and provider, so you can see why you might choose one over the other. Both are excellent choices for state management in Flutter, but they differ in the key ways. So here I have created this table so that you can understand it better, or you can take the screenshot for your future reference. So in the Riverpod, build context is not required, but in the provider, build context is required. And inside the Riverpod, we have more compile time safety rather than the provider, because provider follows the runtime checks. Okay. Now for Riverpod, it's easy to test non-widget logic, but inside the provider, it's required the widgets for testing. Then Riverpod can be used outside of the widget tree, but the provider is limited to widget tree. Then in the Riverpod, we can handle the async operations with clear loading error state, but inside the provider, it needs to be handled by the custom handling. So in this lesson, we have explored Riverpod as a powerful alternative to provider for state management in Flutter. And we covered the basics of provider, how to handle asynchronous data, and dive deep into more complex use cases like state notifier. Riverpod gives you greater flexibility, testability, and compile time safety, making it an excellent choice for both small and large Flutter projects. If you are new to Riverpod, give it a try in your next step and see how it transforms your state management approach. Thanks for watching, and don't forget to like, subscribe, and hit the notification bell for more content like this. See you in the next video.